And you're just substituting x plus h in first, then subtracting the function f of x, but make sure you distribute that negative. So that's why I write it separately and distribute the negative. And then make sure that you're squaring x plus h first before you multiply by 3, and then it's just a matter of simplifying the numerator, factoring out an h, and divide the h's numerator and denominator. So I have 3x minus 5 minus 3 is 3x minus 8. So 1, 6 is not on the graph, it's an open circle. Then I have the other part, which is y is equal to x plus 2 for values for x less than or equal to 1. So now the y-intercept is 2, and the slope is 1. I'm going to go over 1 and up 1. Now I'm going to go up to a value where I substitute in 1. So if I substitute in 1, I get y is equal to 3. So if I go over 1 and up 3, it's going to include that point, and then it's going to come down and then it's going to come down from there this way. So it's a piecewise function. It is split. It has a y-intercept of 2. The point 1, 3 is on the graph, and then it goes down from there. The point 1, 6 is not on the graph, but now it goes up with a slope of 2 from there. So they're different here. Yeah?
How did you get y equals 6?
I substituted in 2 times 1 plus 4.
Oh, okay.
Just substituting into the equation. Now that of the 6 points is worth 4 of it, and now there are 2 other parts to it. Evaluate, let's say, f of 3 and f of negative 1. So when it's f of 3, we're using 2 times 3 plus 4. We're using the first part because x is greater than 1. So we're substituting into that one. And I'm getting a value of 10. For x is equal to negative 1, I'm substituting into the second one, and that would be negative 1 plus 2 or positive 1. So I picked one that was greater than 1, so I would be using the top equation. I picked one that satisfied the second part, and so this whole question on part 2 is worth 6 points, probably 4 to graph it, and then 1 for each of the substitutions. Yes? So again, first the negative 3 goes into the g function. You get an answer, which in this case is 15. Then put 15 into the f function. Next, we're putting just x plus 1 into the f function. So that's 2 times x plus 1 plus 1, or 2x plus 2 plus 1, or 2x plus 3. Next, we're putting x into the g function, which it already is, and then we're putting the g function into the f function. So we're putting 2, replacing the x with the g function, plus 1, and simplify. So we're getting 4x squared minus 6 plus 1, or 4x squared minus 5. Now we're putting the f function into the g function. So it's 2 times, and since we're putting in x plus 1 squared, I'm going to put x plus 1 written out. I'm going to multiply by 2 after. So, and then after you put in 2x plus 1 into the f function, you square it, then you multiply by 2, then you subtract 3. So this is going to be 2 times x squared plus 2x, the inside outside, plus 1 minus 3, or 2x squared plus 4x plus 2 minus 3. 2x squared minus 4x minus 1. Oh, I'm sorry. This had a 2x in front of it here. I'm going to have to just put a 2x in here. This should have been 2x times 2x is 4x squared. 2x and 2x is 4x in the middle plus 1. So that then I have, I'm going to get rid of all of this. So now I have 8x squared plus 8x plus 2 minus 3, or 8x squared plus 8x minus 1. Now to substitute 3, and since I already have an equation, I can either go into F, get an answer, then go into G, or just put 3 into what I just worked out, which is 8 times 3 squared, which is 9, plus 8 times 3 minus 1, or 72 plus 24 minus 1, or 96 minus 1, which is 95. So since I already found